Today's topic is ML deployment on AWS. So part of our MLOps bootcamp that we do, at the end we leverage either AWS, Azure, or GCP Cloud, and we also deploy this in traditional methods too. But then we got a lot of requests for us to deliver, asking to deliver on how to deploy it on AWS. We were not able to accommodate it in the masterclass itself, the bootcamp itself. So we are doing this additional session. This is a small subset of our big bootcamp of about 60 hours, where we'll be teaching you machine learning and how you push the models into the deployment using either GCP or Azure or AWS. This is one of the small snippet of our MLOps bootcamp. So over to one of our subject matter experts, again. Please take it over. Thank you for being with us today.
Yeah, thanks, Shrath. Hi, everyone. I welcome you all in this masterclass of ML deployment on AWS. So I'll be taking the session and I'll be taking one example. So firstly, I'll be discussing like what is AWS, right? What are the different components of AWS? And then we'll be taking one use case also, where I'll show you like how we are going to deploy it on the cloud. So I'll quickly share my screen.
You can see your screen.
Okay. So when we talk about the machine learning deployment, right? So there are two things. One is the creating the models, and second part is deploying it on the production part. So most of the people, they are familiar with the model creation in the sense how to do the data cleaning, how to pre-process the data, how to do the feature engineering, how to use the different models, right? Machine learning models like linear, logistic, decision tree, and that's it. Okay. So but they do not know how to deploy it in the production, right? So how to make it more scalable. That is where the role of MLOps engineer comes into the picture. Okay. So that is what we are going to see here. Like how we are going to deploy the project, right? And how we are going to make the real world impact, right? So machine learning is transforming the decision making, but building a model is only half the battle. Okay? So how do we bridge the gap between the data scientist notebook and a scalable real-time application? Because when we create the models, we create it in the machine learning in the Jupyter notebook, basically, or in the VS Code, in the Python notebooks, right? But that is not something which you're going to deploy in the production. Okay? So you need a UI also, and that link should be global link. That if I'm using on my local host, there also it should work. And if I'm sending it on my web application, on my mobile application, right? So there also it should work. Okay. Now, these are the three main pillars we have, right? So when we talk about the end-to-end workflow. So first one is like the AWS SageMaker, right? So this I would say is the brain. So here we will be doing the coding, right? Because ultimately we have to create the machine learning model also, right? I have to import the data, I have to do the data cleaning, I have to try out the different models, right? So that part we are going to do here, right? Because this provides me the access of Jupyter notebook, and in the either I can run it in the cloud itself. I can train my model on the cloud itself, or I can train the model on my local system also, right? On my VS Code, on anti-gravity, whichever the tool I'm using. Okay, but we are going to use everything on the cloud only, right? So that SageMaker, that's why we are calling it as a brain, because here we are going to do the coding, here we are going to create the end-to-end project. Then here you will be creating the model, right? And that will be in the pickle file, right? Because when we talk about the models, they are in the job lab format, they are in the pickle file format. Now you are going to upload it into the S3 bucket now, right? So that is the storage bucket. S3 is the storage bucket in the AWS, right? We have the different components in the cloud. So one component there, right, which is in the pickle format, then Lambda. Now, what do you mean by Lambda? So this will create a REST API for your model. Guys, please go on mute. Someone is unmuted. Please go on mute, guys. Chat received. Okay. Okay. So what I was talking about, yeah. So AWS Lambda, right? So this is another component in our AWS.
Yeah, so we were just thinking there was
Is there
some
any
disturbance in the audio, but I think
is
it's
there any
getting
issue?
clear.
Okay, 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 no worries. So you can let me know, Sharath, right? So if there is
Yeah.
any issue, right? So I'll try to change my network or maybe the headphones. Okay, now the second will be the Lambda, AWS Lambda, right? So this will help me in creating the REST API, right? And that API, I can share it with any UI part. Okay, so there are three components. One is the SageMaker, one is the Lambda, which will be creating the REST API, and then the front end, right? User interface, how it will look like in the mobile application if you're using the mobile application or the web application. Okay. Now, now, when we talk about the AWS SageMaker, right? So it is the managed ML engine, right? So where you'll be having the notebook instances, right? So Jupyter notebook basically, right? So here you can do the coding part and everything. And training the jobs, right? So here you will be having the compute also. Okay, so compute in the sense, obviously you need the CPUs, you need the GPUs also to run the models, right? To run the codes, right? So that gives that flexibility also, right? That gives that infrastructure setup also. And the endpoints in the sense like once you have created the pickle file, right, you are not going to store it in your local system, right, you are going to put it somewhere, right, that is called as the endpoints, that you are going to do the live hosting of this thing onto the interface, right, this thing. Okay, so this is what it means. Now this is the entire workflow of the SageMaker is the first step, right, the brain. You'll be uploading the data set, you'll be doing the pre-processing of it, you will be selecting the algorithm whichever you want to choose, right, or you'll be choosing the different algorithms, you'll be doing the experiments in that hyperparameter tuning, and then you are going to train and evaluate it, right, and then you'll be checking how much accuracy you are getting, and then after that you are going to deploy in the sense endpoint, right, you are going to deploy it on the endpoint. Okay, I'll show you everything, I'll show you practically. Okay, now, so till here, what we have done, the pickle file, the model which we created in the pickle file, we have deployed it on the endpoint. That is the first step which we have done. Now the second step is, now I cannot access that directly, right? If I want to create it, if I want to access it directly, I cannot access it, right? So what I have to do, I have to create a REST API for that. And for creating the REST API, the AWS Lambda will come into the picture, right? So because it provides the serverless bridge, right? So it's like a bridge between the UI part and your model. Okay, so it's a zero server management. So when we say zero server, so that doesn't mean that it is not using the server. Obviously, it is using the servers, right? It is using the cloud server. So when we say zero server, in the sense, we as the humans, we no need to take care of this thing, right? So it will do the auto upscaling also. It will do the auto downscaling also. Upscaling in the sense, if we are getting a lot of requests, automatically it will start increasing the servers, right? If you're reducing, if you're getting less requests, then automatically it will start reducing the clusters, right? The benefit we will get out of it is costing part, right? Our costing part will be managed with this. Event driven executions, right? Event driven in the sense, as and when we are getting the request from the UI, right? So then only it will get trigger, otherwise it will not trigger. Infinite scalability, right? So you can, I mean, hundreds and thousands of users can access the application at the same time. Okay, so that is what this thing is, right? So you can, that API can be used by hundreds and thousands of people at the same time, so it will not crash, right? So this thing. So the security and the scale of decoupling. So what does that mean? That if Lambda will not be there, right? The REST API, the bridge will not be there, then it will be very difficult to connect your UI part with your this thing, right? Because there are so many other things are involved, right? Because your model can be hacked by easily, right? So if you're not having a good security over there, right? If you're not managing those things, so Lambda acts as a secure, scalable bridge, right? So if one of your server is getting problematic, right? So like recently you might have seen, like in the Iran and Israel war, right? So there was issue in the data center in the Amazon, right? So what they have done, they have immediately transferred the data to the other regions, right? So their data is scattered on the different regions, right? So this kind of flexibility it gives us, right? So it shields the front end from the complex ML backend, formats the payloads, and manage traffic spikes effortlessly. Traffic spikes in the sense, we are getting thousands requests at the same time, right? So due to some campaign, due to any reason. So this is what it means. Now, this is the user, this is the case study which we are going to do now, right? So we are going to take one data set in which we'll be having three variables. One is the number of bedrooms, number of bathrooms, right? Number of square feet, how much is the square feet, and the year built, right? So these are the four variables which we are going to take, right? So we are going to talk about a now machine learning problem statement, right? We are going to take one machine learning problem, right? We are going to take one machine learning problem, right? So where we are going to train the model based on these four independent variables, and my target variable will be price of the house, right? So I want to predict the house price based on these four independent variables. Okay. So what we are going to do, the first step is that we are going to do the training part. And where exactly we are going to do the training? In this one, right? AWS SageMaker. So firstly, we'll go to the SageMaker. There we'll create an instance, and there we will open the Jupyter notebook. There we will be doing the coding. Coding in the sense importing the data, doing the data cleaning, trying out the different models, right? And this thing. And then we'll be doing the regression algorithm, right? We'll be using the random forest, linear regression, whatever we want to use. And then we are going to deploy it on the endpoint. Okay. So this is what it is written. The regression model is trained on the historical data to predict the price target variable. Once evaluated for the accuracy, it is packaged into an active SageMaker endpoint, perpetually listening to this. Now the second step is then the Lambda. AWS Lambda will come into the picture, right? Because the PKL file which we have created, we have already deployed it on the endpoint, right? Using that endpoint, we are going to create the REST API. And who will be helping us? Lambda part. Okay. So it will receive it will process and secure it, and the fetch, right? If you will see the point number one, receive. So receive means it will grab the input from the front end via function URL or the API gateway, right? So you might be having some UI also. That UI can be based on the HTML, CSS, JavaScript, Streamlit, or any other platform. Okay, so it will extract that request. It will take that request. It will do the CORS. What is CORS? This is called as a cross origin resource sharing. Now, what do we mean by this? That your model is on the AWS, your website is on the different domain, right? So two different domains are there. So directly you cannot interact two different domains, right? You should have some gateway between them, right? Who will be helping us to connecting, right? So for that, be using this thing, right? Otherwise, any hacker can easily access your website and he can easily hack your website, right? So you will not be having this kind of cross origin resource sharing control. And then formats the JSON payload, right? Send it to the SageMaker endpoint and retrieves the price prediction, right? So that request will go to the SageMaker, right? It will extract the target variable, right? So whatever the inputs we are getting from the user, so for that it will be extracting it. Okay. So this is the UI part. Okay. So front end. So front end can be in any language, right? It can be in the HTML, CSS, JavaScript, right? Or any other language or the Streamlit, whatever we are using. Okay. So this will be your complete architecture request flow. So user enters the home details, point number one, on the UI, right? It will be ending. It will generate a HTTP request, right? That will go to the REST API Lambda API URL. With that, it will go to the SageMaker to predict it, right? Because ultimately we have to hit that model.pkl file, right? So it will get the value. That value go back to the Lambda, right? And from there, it will go back to the UI part. Okay, so this will be the entire workflow. Okay, so these are the three things we have, right? AWS S3, this is the bucket, S3 is the bucket, right? So where you will be keeping the UI, where you'll be keeping the raw user inputs, right? Whatever you want to keep, right? So this is like a storage. Lambda, right? So middle layer, which you already have discussed, and the SageMaker, right? Which we already have discussed, right? Okay, so now these are the, I'll talk about this masterclass takeaways in some time, right? And this one. So let's talk about the hands-on implementation of it. Okay, let's talk about the hands-on implementation, right? So now theoretical part is clear, right? So now let's talk about the practical implementation. Okay. So the first thing is that we have to create the account on the AWS, right? So once you will create the account, right, it will ask you for your credit card details. Okay, so you just need to enter your credit card details and it will deduct like 1 or 2 rupees, right? So one to authenticate it, right? Once it will be done. Now this is how your homepage will look like, right? So this is how your homepage will look like, right? This is the homepage. This is how it will look like. Now we are going to use the different components of the AWS, right? What are the different components? So we have SageMaker, right? So we have Lambda, right? In addition to Lambda, in addition to SageMaker, what else we'll be having? We will be having the endpoint, right? And we will be having the S3, right? So these are the four things which will be having on the cloud platform, right? On the cloud platform, right? On the AWS. And in addition to this, you will be having AWS. You have to make sure that all should be on the same region, right? So when I say region in the sense this thing, right? For example, in my case, I'm choosing the Sydney, right? So in the same way, you have to choose some specific region. Okay, so make sure like every component should be on the same region. If one component is on Sydney, another is on Virginia, then it will be a problem, right? Problem in the sense, firstly, the costing part will be higher, and secondly, it will take a lot of time to predict and execute the things. Okay, and when you create the account on the AWS, by default, you get the $100 credits over here, right? And maximum it can go up till $200, right? Depending on like what are the features you are using. Okay? And the validity is like 6 months of this. Okay? Now the first thing is that we will be opening the SageMaker, right? So here, when you click on this, right, if you will scroll down, right, so you will see here machine learning, right? So these are the different things we have, right? So if I want to go to the storage, I can go here, but I want to create a model first, right? So I'll be going to the machine learning. Just click on the machine learning. So in the machine learning, these are the different uh, components which are provided to us, right? So we have the augmented AI, right, which can create the machine learning models automatically, right? And so many things, right? So, but we are going to see it using the SageMaker AI. And this is used to build, train, deploy the machine learning models. Just click on this. So when you click on this, right, so this kind of screen will get opened. This kind of screen will get opened, right? So here you have to create the domains, right? So like in my case, I already have created the domain, right? So if I'll going to create it here, so it takes like 15-20 minutes to create it, right? So that's why I already have created the project like yesterday. So I'll quickly show you that part. Okay. Now, if you'll, this is the domain, right? So if you want to create the domain, just click on the create domain and it will take like 15-20 minutes to create the domain for you. Okay. Now just click on this, right? So I already have that domain, right? So I'm just opening it, right? So in this, what we will be doing, we will be opening the, this one, Open Studio, right? So Open Studio means, so this will give me the access to use the uh, servers, right? And to the access to open the Jupyter notebook and everything, right? See, this is how it will look like. This is how it will look like. Okay. So in your case, you have to use the Jupyter lab, right? So when you click on the Jupyter lab, a new notebook, this is like a Jupyter notebook, which will get opened, right? So in my case, I already have this. Okay, so just open the Jupyter lab. Okay. So in your case, it will be an empty folder, right? In my case, I already have created the model so that I can quickly walk you through it, right? Otherwise, in your case, it will be totally blank notebook. Okay. So what you have to do, right? So here you will see the this thing plus, right? So when you click on the plus, so here you will get to know like what exactly you want to create, right? You want to create the Jupyter notebook, you want to open the terminal or what, right? So you can click on this IPY kernel. So when you will click on this IPY kernel, right? So this kind of empty file will get opened. Okay. And after that, what we have to do? Firstly, we import the file, and which is the file we are going to use? We are going to use this file. This file will go as the input, right? So where I have these four as the independent variables, and this is the target variable I have, right? So intentionally, I'm taking a smaller data so that it can run quickly, right? So we have 1,000 observations. So based on the square feet, bedrooms, bathrooms, and year built, right? I need to predict the house price. Okay. So what we are going to do, firstly, you have to import the file here, right? So using this upload button, so this is the upload file. So using this, you'll be uploading it and this file will start appearing here. Okay. After that, what we have to do in this, just import this thing. So here the prerequisite is that you should know the machine learning part, right? So if you do not know the machine learning part, then it will be difficult for you to understand this masterclass, guys, right? Because this is more specific about the deployment part. Okay? So here what we are doing, we are importing the libraries, right? So pandas, numpy, train test split, and we are using the linear regression, right? So we are loading the data set, right? So the data set is present here. So we are loading it. We are using the info method to check how many rows and columns are there. This is my describe method. right? Here we are dividing into train and x and y. X means all the independent variables, y means dependent variable, and here we are defining the data into the training and testing. So we are dividing the data into 80 is to 20% ratio. Okay, and here we are training the model using the linear regression. So this is the model which we have created. This is the model which we have created, right? And we are just doing some basic validations by checking the predict model dot predict. These are the predictions for the testing data set. Testing in the sense 20% of those 1009, which is approximately like 200. So for those 200 rows, these are the predictions. Now this is the important part, right? So here what we are doing now, the model which we have created, right? We are saving that model. We are dumping that model in the PKL file, in the pickle file format. This is called as a pickle file format. In the pickle file format, we are saving this model, and now we are going to push this model in the S3 bucket. Okay. So when we work in the machine learning projects, right, or in the deep learning projects, it's always good to zip the model, right, using this tar file, right? Using this tar file, what we are doing, we are zipping this PKL file into this, right? The benefit is that it will take less space also. And in the new features of this AWS recently, 3 months back, 6 months, 4 months back, right? We have the option to, upload the PKL files also, but recently they have removed the option of uploading the PKL file. Now we have to upload the zip file only, right? The star file only. And where exactly so here what we are doing, we are converting that into the model.tar.gz, right? So in this we are importing it, and you will see this is the file, right? Model.tar.gz. Okay, this is the file. So here we have created the file. Now we are going to push it into the S3 bucket, right? Now I'll show you the S3 bucket. Again, go to the home page of AWS. This is the home page, right? So in the this one, right, at the bottom you will see the storage. At the bottom you will see the storage. So when you click on the storage, so here you will see these are the different types of storages we have, right? So we are going to work on the S3. So it is scalable storage in the cloud. So when you open this S3 storage, right, so in my case I already created the bucket, right? But in your case you will be creating the bucket here. Okay, now what we are doing here, right, if I'll show you, we are saying Boto client S3, right? So this is how we import it. Upload file. We are uploading the file. Which file? Model.tar.gz, right? And this is the name of the bucket we are giving, right? So if you will see here, and it will automatically create the bucket for me. Okay. So if you will see the bucket name, so this one, SageMaker Studio, this VD20 RHA. Okay, so see this one, SageMaker Studio, this one, right? So when you are going to run this, automatically this will create that bucket also, and it will create the model inside that. This is a folder, and this is the file which we are pushing, right? This is the file which we are pushing, right? Now see here, go inside it, you will see one model, right? So when you will see, this is the file. Okay, so this is the file which we are pushing it into the S3 bucket now, right? Because you cannot keep it in your local system. Now using that, right, what we are doing, we are doing the pushing it into the endpoint, right? So sklearn, this is the code for that. Using that, we are pushing it into the endpoint. Okay, now what is this inference.py? So this is the code which you have to create, right? So this will be helping me for the prediction part basically, right? So once we'll start receiving the request from the users, right? So for that, it will be helping me to do the prediction part from there, right? Model.predict, right? So first it will load the model, and then it will predict the model, right? So this is what we are doing here. And here we are just doing some basic validation checks, right? So we are just passing the value here, and we are getting the output, right? So which value? See, we are passing the square feet, number of bedrooms, bathrooms, and year built, right? So square feet, bedroom, bathroom, and year built, right? And based on that, we are getting the value. So that means our model is working fine in the endpoint, right? Because we have posted it into the endpoint. Okay, so in the endpoint we have posted it, and using that we are testing it. You can test a single observation also. You can test multiple observations also. You can pass the entire file also for this thing. Okay. Now, this is always a good practice to delete it, right? Because when you are doing it for the learning purposes, right? Otherwise, you will see it charges you, right? So AWS charges you because you are consuming some space for the endpoints. Okay. So the first step is done, where we have created the model, right? The first step is done, right? So where we have created the model, the SageMaker part, plus the endpoint part, right? And the output we have got from here is that we have uploaded the model in S3 bucket, right? In S3 bucket, we have uploaded the model. Now, what is the next second step? Now we have to bring the Lambda into the picture. Now, what the AWS Lambda will do, it will take that endpoint into consideration, and using that, it will try to create a REST API for that. Okay, so let's see that part also. So now let's go here, right? So let's go to the AWS homepage. Right, so this is the homepage we have. Okay, so in the search bar, just search for Lambda here. So when you search for the Lambda, this is how you will get it, right? Run code without thinking about the servers, right? So when you click on this, right? So here what you have to do, in my case, I already have created one function. In your case, what you have to do, you have to create the function here, right? So once you will create the function, right? So here you will be right. So this is how the window will get opened, right? So this is the window which will get opened. Okay. So if you scroll down, and here also you have to make sure that this should be same. The region should be same, right? If I'll switch to some other region, my information will be lost, right? So in that I'll not be able to see it. That is the first problem. Second problem is that it will take a lot of time to, pass the information from one region to another region, because my SageMaker is running on one region and this will start running on the another region. Okay. Now see, this is the code which we will be writing over here to generate the functional URI. Okay. Now see, we are importing the JSON, this one, right? So this is the name of the endpoint which we are creating. This is the name of the endpoint. Okay. So how you will get to know the endpoint where we have deployed it? Again, click on this, click on this one, right? Homepage. Okay. So here, just click on this, right? And here you will see machine learning. Right? Just go to the machine learning, just go to the same thing, SageMaker AI, right? So when you go to the SageMaker AI, right? So if you scroll down, see earlier we went inside the domains, right? Which was opening the studio for me for the Jupyter notebook. Okay. Now, once we have deployed it on the checkpoint, on the endpoint, right? So that will start appearing in the deployment and inference, right? So here you will see the endpoint. See, this is the one which we deployed it, right? So where we deployed it, how we deployed it after this step, right? So where we are saying deploy model checkpoint, right? See, this is the name, SageMaker Studio. This is the model name, right? So if you will see here, the same thing we are opening here, right? So this is basically my endpoint, right? This is my endpoint, right? So what I have to do now? So using the Lambda, right? Using the Lambda, I have to use this particular endpoint. Okay. So this is for one model. In the same way, you can have multiple endpoints here, right? So let's suppose this is the first version of the model, the second, then third, then fourth, right? You can have multiple versions. Okay. Now let's go to the Lambda, right? So where we were creating it, right? So this is my Lambda. And see, this is what the endpoint we are giving. This is the name which we are giving for this one. Okay. So SageMaker, Scikit-learn 2026, 313, and so on. So just give the value here, right? SageMaker, Scikit-learn, this, and so on. Okay. Okay, so after that, what we are doing here, we are creating the handler, right? So this will make sure, right, that which all websites can access my API. Okay, so here, if we want to give any control, so I can give here control also. Okay, so now we are, this is just the input part we are taking, right? So we are taking 4 inputs from the user, right? We are taking the square feet, bedrooms, bathrooms, year built, right? So we are just wrapping it in this, right? So we are passing this one. So this is the code which we are doing, right? And then after that, you are going to deploy this, right? And what it will do, it will create this API for me. This is called as the REST API, right? Now our job as a data scientist or a MLOps engineer, our job will stop it here. Okay. So our job will stop it here, that whichever the UI developer will be there, I'll be just sharing this UI, this link with them, right? Because this is the one which is called as a REST API. and they can write it in their codes, and they can access my machine learning model using this REST API. Okay, but here we are the UI developers also. Okay, now I'll show you. Now we'll move to the next step. Right now we'll move to the next step. See what we have done. So the first step is done, which we created the model. The second step is also done, that we have created the REST API. Right, this step is also done. Now the third step is, now I have to create the UI part. Right, because how you're going to share it to the end user, right? You are not going to share this thing to the end user, right? So you have to share some UI part to him. Okay, so for that I have to do some UI part, right? So it's up to us. It's basically on the UI developer, right? So whether he is using the React code for that, whether he is using the Python code for that, whether HTML, CSS, JavaScript, Streamlit, right? What exactly he is using, right? For our convenience, we are using the HTML, CSS here. Okay, so this is just the UI part, that how the background color will look like, right? So this is not our role. This is not our role as a machine learning engineer. This is the role of a UI developer. Okay, so let's suppose this is what we are doing. Now, what I want to show you here is the main important part, that here we are going to take the input from the user, right, which is the square feet, bedrooms, number of bathrooms, and the year built. Okay, so these are the inputs, right? And then we will be having the predict price button, right? So this is the on click. On click in the sense, it will be a button which will call this function, right, which is the predict function. And what this predict function is doing, so here it is just taking the values and it is checking whether the values are not null, right? If any of the values is null, then it will say please enter a valid value. Now the important part is this part, right? And here we are calling that REST API. Okay, so this one basically, which we have created here, https g2g4l, right? https g2g4l, right? Lambda url ap southeast 2 on AWS, right? url ap south, this thing, right? So what I was telling you, our job will stop here itself, but we are sharing this link with the UI developer, right? So UI developer will basically create this kind of code. Okay, so where he is going to pass the post request, this one, right? And it will do it, right? So that's it. So this will create a HTML file for me, right? So this is creating a HTML file for me, right? Or uh, the link or anything, right? So wherever the UI developer is going to deploy that application. Okay. Now, what we have done, so that file, right? So that file we have saved it here. This is the file, right? So if I'm going to open this file, right? So as of now, it is opening in my local system, right? So if I'll pass here, square feet is, let's suppose, 2000 square feet, number of bedrooms are 3, number of bathrooms are 2, year built is, let's suppose, 2015, right? And click on predict price, right? It is predicting the price perfectly fine, right? So my application is working fine. Okay, but now if I'll share this link with you, will you be able to access it? The answer is no. The answer is no. So that means I have to make this link now global also. I have to make this link global, so that if I'll share this link with you guys, so you should also be able to access it. So how we are going to do it? This HTML, right? Now I'm going to upload it on the cloud platform, right? So in the S3 bucket, right? So if you'll see in the bucket, right? So I have created one house price 303. So here I have uploaded this HTML file, right? So here I have uploaded this HTML file. Now if I click on this, and here you will see that object URL. Now this is the global URL, right? Now this is the global URL, right? Now if I'm clicking on this link, right? I'll just copy this link. I'll just copy this link, right? And I'll put it over here. Now this is a global link, right? So here I can give like 2000 square feet, right? Number of bedrooms are 4, bathrooms are 3, year built is 2016, and click on predict price, right? It is predicting. So it is working on this here also, right? And if I'm going to open it in the incognito window, right? So where I'm not logged in into this part, into the AWS, right? So if I'm clicking on this, right, and see, still it is able to work here. And if I'm going to share this link with you guys, right, so you guys can also access this particular link. Okay, so this is what the deployment is. This is what the deployment is, that we created, and everything we have done it on the cloud, right? So starting from the model building, right? So starting from the model building, right? So how we're loading the data, how we're running the Jupyter notebook, everything. Then we were saving it in the pickle format. From the pickle format, we were converting into the tar file, right? So then we were pushing it into the this one, what we call a bucket, Bucket in the sense like bucket also and the endpoint also, right? On the endpoint also. Okay, so then I'll be accessing that particular endpoint to create the REST API, and that REST API will be used by the UI developer, right? UI developer will use that REST API, right? Just like here, this is the function which we are creating. Okay, so but this will not be our role. This is just I'm showing you like how it is done. Okay, so here that REST API URL will be passing here, right? Now any person who will be hitting to my website, right, and he want to access this, right, so he can access it globally. He can access it globally, guys. Okay, so this is the entire flow of it. Okay, now I'll come back to the PPT. Now, right now you'll be able to understand the entire workflow. Now try to uh, recollect this PPT. Okay, so user enter the details of home details, right, which is on the created by the UI developer, right? So just like on the incognito window when I was going, I was entering the number of bedrooms, bathrooms, right, and square feet. And when I was clicking on the predict button, so internally what was happening? The request was going to the Lambda API URL, right? So that was hitting the endpoint because my model is deployed on the endpoint only, right? So if you remember, my model was deployed on the endpoint, this one. So internally it is hitting this because this is responsible for giving you the for giving you value back, right? And make sure this should be active in service, right? Because if it will be deactivated or inactive, so then you will not get the response back. Okay, so that will go here in the SageMaker endpoint, right? So SageMaker calculates the prediction variable, right? So this will return the value as a JSON to the Lambda, right? And it will give the value to the UI back in the exact format. And then that will start reflecting on the UI part, right? So as an end user, right? So as an end user, we will be able to see only this screen, right? So when I'm clicking on the predict, ultimately this entire flow is happening, right? It is going to the Lambda, from Lambda to SageMaker endpoint, from the endpoint back into the Lambda, and from back into the Lambda to the UI part, right? So this is the step which is going behind the scenes, guys. Okay, so now coming back to the remaining slides, right? So these are the takeaways, right? Managed life cycles, right? SageMaker centralizes everything from the raw data exploration in Jupyter to the real-time endpoint deployment. Serverless power, Lambda constructs highly scalable, zero maintenance APIs that respond instantly to events. Okay, so this is the power of Lambda, right? That here we have the option of auto scaling, upscaling, downscaling, right? So if we'll expect a very high traffic on some days due to any reason, due to some festive season or due to anything, okay, so if we are expecting a lot of traffic on our website, automatically it will take care of those things. Decoupled design, decoupled in the sense the interaction between the UI and the local your local model. Okay, so separating the user interface from the ML model guarantees robust security and seamless JSON this thing, right? And instant global reach, right? S3 static web hosting upgrades a local predictor script into a globally accessible web application. Okay, so you now possess the architectural blueprint to take an ML out of this, right? And next step is you can start creating your own application here. Okay.
Thank you.
So how was, yeah, Sharath, over to you.
Please complete. How was the session? It was
Yeah,
great. Thank you so much.
okay.
It was a great session. I see some questions and hands raised up. That is why I unmuted. So I'll go one by one. James, who was there? Again, sorry to interrupt. Did you have anything to add on?
Uh, from the AWS side, yeah,
No,
there
no.
are
Yeah.
multiple. Yeah, from
Okay.
the AWS side, there are other ways also of deploying. So here, what we have discussed is that how we were creating the model from the scratch by ourselves, right? In the same way, we have some auto ML features also. So auto ML in the sense, the AWS will run the application by itself. It will automatically try to do the hyperparameter tuning, and but it takes a lot of time. So it can be completed if it can be completed in 10 minutes, then it will take like 2 hours. So that kind of issue, and costing will also be on a higher side. But yeah, this is what it is.
James, I'm going to ask you to unmute. I see you have question or was it a mistake? I know this hand was raised for last 40 minutes. I'm allowing you to talk. If you have a question, you can speak up. Otherwise, you are unmuted now. James?
Can you hear me?
We can hear you now. Did you have a question,
Oh,
James?
okay. My bad. I didn't have a question. It's just like when I joined, I couldn't like hear you guys talking, so I wasn't sure if this is gonna be a presentation or like an with audio.
Understood.
But no, I'm good on your presentation. Overall, yeah, I learned a lot. Thank you.
I'm going to go ahead and mute. Mohsin, I'm going to unmute you. You just raise your hand.
Oh, well, I do know.
So you have a question, James?
Yeah, I do have a question now.
Yeah, go ahead, please.
Okay, so like I've been doing like training models through my master's program.
Okay.
But like since if I'm gonna work with a large data set, I think I need like a better laptop or like better setup. But like using the clouds, I know like AWS, I have to pay for it. Do you have any recommendations like for like if I want to go into building something that is production ready, but cost effective? What can I do?
So yeah, so this question is related to the hardware part of the laptop, right?
Yes.
Yeah. Okay, so I would recommend at least 16 GB of RAM should be there. I mean, in 8 GB also it is fine, but if you want to start integrating the Agentic AI, Gen AI, and the MLOps part, LLM ops part, right? So there we'll be using the Dockers, containers, and other things. So I would recommend 16 GB of RAM and i5 processor, right? So that should be the minimum. Okay, and in C drive, 512 SSD, GB SSD, or 1000 GB SSD, that anything is fine, right? At least 512 GB SSD. But in terms of RAM, at least 16 GB should be there, right? With 8 GB, it will perform very, very slow.
Okay, thank you. James has another question. Okay, James. I disabled.
Sorry. If I want to familiarize myself with the AWS flow, how much do I expect to pay monthly for doing the stuff that you did?
See, I'll tell you, like when we create an account on the AWS, so it generally gives us like $100 credit, right? And it can reach up till $200 credits also, right? Depending on like what are the features we are using. So minimum is 100, maximum is $200, depending on what are the different functionalities we are using. And the validity is like 6 months for it. Okay, so while practicing on the cloud, because anyways we are just doing the practice here, so I would recommend use the small data sets, like just I have used of 1,000 rows and 4 columns, and try to use all the features, right? So I would say within $100, within $150, right? So you will be able to explore most of the features of the AWS.
Okay. But
And
like,
And one more thing, like once we are created with the project, right? Immediately after that, try to delete the endpoints. Try to save some space on the storage also, right? Because whatever the things you are uploading on the S3 buckets or whatever the endpoints you are using, right? So for that, the costing is involved. So let's suppose today you're closing the laptop, and the next morning when you will wake up, right? So you will see like $10 are gone or $15 are gone because during the night time, right? So that was running behind the scenes. So that's
yeah,
why it
that's
is.
that's that's something I'm trying to get better at. Like when using AWS, like I need to keep track of like knowing what is charging me and like what I need to either like delete or turn off.
Even the turning off will not help, right? Although you are going to
Oh.
turn off, so still it is taking the space, right? The thing is the instance is not active, right? It is not consuming your CPU, GPU, but still it is taking the storage part, right? So deactivating it, right? Just reduce the costing part, but it will not remove the costing part at all. Okay. And in the
Got it.
dashboard, you can see that like which are the things which are costing us and how much on all
Got
the
it.
cloud platforms, on the GCP also, if you're using the GCP or if you're using this. So there is a page of, there is an option of this thing, billing and costing. So there we can see like how much the costing is involved.
Got it. Thank you.
Yeah.
You have any other questions, Sajin, Swai?
No, I'm good. Yeah, that's it. Thank you.
Awesome. Thanks all. Bye everyone.
Yeah. Bye.
Thanks everyone.